Good morning, everyone. Today we are going to start on the topics of collection framework. In the collection framework, we have the several categories. First, we will go with the introduction and all the things, and we will go by one. First, why we need the collection framework and what is the story of the collection framework is nothing but suppose you already use that arrays, right? You already use the arrays and all the things. Those all can be provided by your Java. Those are comes under collection. Normally, suppose what are the drawbacks you are facing by using the arrays? Firstly, by using the arrays, you can facing the issues of fixed size to the arrays, and it will not be resizable, and means it will not come strings and it will be not expand. Suppose based on the elements you are insertion, it will not automatically expand, and based on the deletion of the elements in that particular array, it will not be shrink. These are the drawbacks you are facing by using the array. Suppose you know the count of how many elements you can insert into a array, then it's fine, you can declare the size to the array and uh, declare size to the array, and insertion and deletion operations you can perform. Suppose you don't know how many elements you can add into the particular array. Normally these all are comes under a data structures. Data structures is nothing but a you have a data arranging it in a proper way, that will be called as a data structure simply. Normally consider these are all are we are using for the storing of data, right? Data is nothing but some information which was raw data provided by you. Suppose a group of students, you have a group of names, they can provide it to you. Take the example of one class. In a class they don't know how many people can be joined or not. Okay, they don't know any fixed size. Suppose take the example of this batch. Initially we don't know how many can be joined into that batch. So how can we declare an array to maintain or store the data of the particular students, how many students can be joined in that or not? In such cases we don't know the how many, we don't know the exact size of storing the data, so there might be a difficulty to store the data, right? So in those cases we are going with the normal in every programming language, we are going with the data structures of linked list, single linked list, double linked list, like that we are going to that data structures. But here your Java can provide the inbuilt data structures to you. Normally you can also create the data structures by using the classes for normal single linked list, double linked list, like that. But at the future your Java can provide a one collection framework to your programming simplification. Java collection framework is a set of interfaces and the classes to maintain the storage and the data. Storage and data. Okay. This is a simply collection framework. Collection framework is nothing but a simply framework is nothing but a set of existing methods or set of existing libraries. Okay, like the way collection framework, Java collection framework, Java collection framework, it is a set of interfaces and classes. We have several interfaces and several classes, we will discuss that. Interfaces is nothing but simply a blueprint of a class. Classes are existence to your methods, existing methods and all the things. Interfaces and the classes to maintain the storage and data, to maintain the storage and data. These collection frameworks and all the data structures will helps to you. Normally, take the example of your laptop or anything. Laptop can also store the data, right? How the way it will store the data, how the way it will store the data, that means it will be maintain one stack or queue, or it will maintain one set of array, anything. One type of collection it will be used. In point of Java it will be a collection, in point of Python, and in point of any other program, the terms will be the different. At final, it has to be one data structure to store your data. At final, it will be one data structure to store the data. And the collection framework as categorized into different types. One was the list interface, set interface, map interface, queue interface. List, set, map, and queue. We all that see. First, before going to that, how that collection framework hierarchy. You want to know the first collection framework hierarchy. The collection framework hierarchy is nothing but how the collection framework interfaces and the classes will be. See, suppose if you are taking the example in a thread concept, thread is a class. It has to be inherited from the, sorry, suppose if you are creating one thread, it was inherited from one thread. Thread is inherited from runnable, right? Like the way it will be hierarchy. In the same way, we have hierarchy in the collection framework also. In that, first thing, iterable. Iterable is the parent to the all the collection framework. This iterable has the two things. One was the collections. One was the collection. In the same way, another one was the map. Map is a separate hierarchy, and the same way we have the other things of list, set, and queue. These are the these are the three interfaces comes under the collection. The three interfaces comes under the collection. One was the, another one was a queue. These are the three interfaces. That means by you are not creating any objects to that, you directly not access the methods of it also. So it has some classes in inbuilt. It has some classes. We will discuss that. And these are under the iterable. Okay, maps is a separate hierarchy. Okay, maps is a separate hierarchy. It will not comes under this type of collection. Collection here we have the set, list, and queue. These are the things. And the list has the types of array list, vector list, linked list, and stack. These are the four types under the list interface. These are the classes. Array list is one class, like the same way vector list is one class, and linked list is one class, and also stack is one class. Okay, first we'll note it out. In the collection framework has the three interfaces. Three interfaces. Those are list, set, and queue. Okay, and map is a separate hierarchy. We'll discuss that. Collection. In that first list interface, I am talking this as a list interface. So you are not creating any object to that list. This collection framework completely depends on a objects and all the things. List interface contains the first one, array list and vector in the same way. ArrayList, vector, stack, stack, and linked list. This is the first one. In the collection framework, we have the thing of array list, vector list, stack, and linked list. These four are the classes, not interfaces. These four are the classes. List interface contains classes. One was array list, one was vector, one was stack, another one was linked list. All can be follow the same methods, pre-built methods and the functions. Suppose pre-built methods and functions are nothing but suppose you want to insert an element to the array. If you want to delete an element from the array, normally these all we are talking about the first thing. We are focusing on the categories of one was insertion for all the interfaces. One was insertion, one was deletion, another one was update, insertion, deletion, update, and how can you create. Okay, these four, based on these four, and after this traverse. Suppose you have an error, how can you traverse in that error, right? Based on these five concepts we have to discuss on the list interface classes. Simply collections are helps to you maintain the storage and the data. Okay, maintain the storage and your data in a better approach of way. In before the collection framework, we are going through the arrays and the what are the own data structures, our own data structures of a linked list, single linked list, double linked list, stacks, queues. These are all the topics of the data structures. We are going through that. But after the collection framework, we are using this collection framework efficiently. Why? Because we are going to the AM also using this all the collection frameworks and all the things. Okay, and before starting into that list interface classes and all the things, you have to understand the wrapper classes. Wrapper classes is nothing but in before we are already see that primitive data types of integer, character, and all the things. But these collection frameworks not allows that primitive data types. Normally, if you are storing an array, right? Array means what? Array means collection of similar data type, right? That means what are the drawbacks you are facing through the array? One was the fixed size you have to be declared, and another thing was similar data you have to be stored. Similar data, that means integers only you can store, or else strings only you can store, or else characters only you can store, like that. Similar data you have to be stored, that means a group of unsimilar data you can't be, right? And also insertions and deletions will be the difficult through the indexes only you can do it. And also element based is not achievable, like all the things you can face by the arrays, right? In that array also you can mention which type of data you can store, right? Integer or char or like that you can maintain. Here also you can go with the array based, and also some unsimilar data also you can store. Both will be fine. You can store the uh, similar data and also unsimilar data, both. Okay, but here you are not using any primitive data types. Here you are using the term of wrapper classes. Wrapper classes is nothing but your Java can be defined one class for the every primitive data type. All the primitive data types your Java provides the one wrapper class. Suppose for the int data type, here you are using the integer. For int data type, here you are using the integer. For the and suppose character or the strings. String is directly class now, so you can use the string. Here also the string, and here also the string. For the suppose character, for the char, here you can use the character. Like this the way every data type can be using here as a wrapper class. Wrapper is nothing but a your data can be stored, that means cover, simply a cover to your primitive data type. By using the wrapper classes only you can achieve the 100% oops, that means 100% Java object oriented programming language your Java can be become. With the primitive data types only your Java can't be 100% primitive data type. But beyond that we are using the wrapper classes. By using the wrapper classes Java becomes a complete object oriented programming language. Okay, and these are the wrapper classes. And first, here we are discussing about the list. How can we these all are under the package of java.util. Okay, these interfaces and all the things under the package java.util. Okay, like your scanner class, like your RDDB systems and all the things, your Java collection framework under the java.util package. Suppose first, how can we create an list interface? First we will discuss that array list. Why? Because suppose you want to go with the list interface na, then one of the class you have to be used must. Why? Because list is an interface. For the list you can't able to create an object, then how can you access it, right? So because of that, one of it you have to be go. First one I'll go with the array list. Okay, in the array list, simply how can I create an array list? Creation. Simply in array how can you create? Suppose int arr equals to, suppose int arr equals to, like this you can create, right? Like this you can create. Like the way how can you create an array list in a collection framework? Simply one way. First way is by using the list interface. List, suppose my list name is list small, list one equals to you have to create an object. So new, suppose array list. Why it will throw an error? Because I have to import this list. Simply I can import here as import java.util dot star, or else I can simply import like a list array list vector. Suppose I can simply import like list, that means particular class or interface can be imported. If you go with the star, then all can be put. So because of that array list, this is the one way of creation. If I am creation like this means I am not declaring any data type to store it. I am not mention any data type to store into that array. This is the one way of creation of your array list. One way. Suppose you want to store the particular data, then list. Okay, here you have to mention, we are calling this open that means less than and greater than symbol as a generics. If you are not mentioning any data type, then it will be store all the things. That means by default it will take it as a object. Suppose here I can store it as integers. Okay, integers list2 equals to simply new. Suppose if you want to store the particular data, then you can mention there in the form of data type. Here also you can pass the data type of integer. If you are not pass that also it will be fine. If you are not pass anything empty generics also it will be fine. If you are mentioning it here, okay, this is the list interface, or else in other way you can directly by using the array list you can create. Array list is one class, right? So by using that class you can create it, right? So array list, by using the array list, suppose here also the same. If you are not mentioning any data type, you can mention the data type of the strings I can store, right? String, my string list3 equals to new array list of. Okay, here we are seeing the three ways. One was list, normally two ways: list by using the interface name, or by using the directly class name. By using interface, by using direct class, you can mention the data type, or else you can not mention the data type, both will be fine. Okay, that's up to you. Suppose you want, you are intent to store only the similar data, then you can mention it, or you are not intent to do that, then no mention. Okay, the same way list1, list2, list3 I have. These are the three types of creation. Okay, we are doing with the three types of creation. Okay, we are creating it, fine. Next we are seeing that how can we insertion. This collection framework all will be depends on predefined methods. That means for the insertion one method, for deletion one method, for getting the size of your array will be one method. Like that everything will goes under one method. So here you have to be remember the methods. That is the thing. Suppose insertion, in the insertion here you have to use the method of add, simply add of. But this is an object, right? So object dot add of, simply suppose I go with the list one dot add of. There I am not mentioning any type, right? So 10, list1 dot add of 10. In the same way list1 dot add of uh, suppose hello, one integer I can add, one string also I can add. List1 dot add of 10.1, one float value I can add. But if you are mentioning any data type, if you are write like this, suppose here I am mentioning it as a integer data type. Suppose here I can write like list2 dot add, list2 dot add, it will throws an error. Why? Because you are declaring it as an integer type, you are trying to add any string to that. So because of that it will throws an error. In that case, that means if you are intent to store different data, then you are simply not allocate any data type to it, or else you can allocate another data type here. It will be the object. Object, it is one data type. That means object data type, you can use it. If you are creating like this, then you can also add the different data to that. So fine, or else if you want intend to one mention one data type, then object will be the place to that. If you are not mentioning means it will by default take the object. Okay, right? Suppose here I can print the my list one, this out of list one. Okay, this will be stored at index 0, this will be stored at index 1, this will be stored at index 2. That means your array list maintains the order of insertion. Remember the term order of insertion. Order of insertion is nothing but which was the first element you are at, that will be at first. Which was the second element you are at, it will be at second. That means one order it will be maintained. It will be in the ascending order, it will be in the descending order. It will be not an issue. It will maintain one order of insertion. That means insertion order it will be maintained. The way of order of insertion it will be maintained. I'll show the different examples. In the set concept, it will not maintain any order of insertion. Randomly it will store, but it will stores in the way of order of insertion. Simply I can print the list one, right? So in arrays, if you want to know the length of a array, then you have a method of length. The same way 10 hello 10.1, the way of order of insertion it will be maintained. Insertion order will be maintained. Okay, that is the thing you have to be observe. One thing what you are see, add method. For the insertion we have the different methods. One was the add, another thing was add all. Add and add all. Add all is helps to you working on suppose in the add you can pass only the one element. In the add all if you can pass one collection. Suppose I can do one thing. Here list one is there, right? Simply these all the elements I have to, my intent to add this list one elements into the list 2. It can't take. Why? Because I have the hello adjusting. So in place of that I'll do one thing. 10 100 1000. Okay, these are the three elements I can store in my list one. Fine. Suppose my intent to add this all list one elements to the list 2. So list 2 dot add all. Simply the difference between add and add all is add is for adding one element, add all is for adding collection of elements. That means one collection into the other collection. That is the thing. Suppose my collection will be the list 1. Okay, and I print the list 1 and list 2. Here I can print the list 2. Suppose if you know in a Python, I think extends is a keyword for elaborating the list. Like the same way here inbuilt it will takes the extends. If you means the list 2 can be stored, not it is storing it as an array. That means suppose if I am write like this, suppose imagine the thing, in place of add all I can use the add. It will throw an error. Why? Because change to add all, because of add all is helps to add the collection of elements to into the another collection, one collection of element into the another collection. Simply if you observe how it will store is it will store it as a separate elements. That means normally there is a way to store like a list in a list, right? 10 100 1000 like this. It has to be, it can be stored, but it will store it as separate elements. Okay, that means every element in this collection will be a one element in the other collection. Okay, in the same way you can also store the nested lists also. Nested list also you can maintain. We'll see that nested list. for a well. Okay, first you have to know the basic things. How can you insertion perform is, there are the two methods. One was the add, another thing was add all. Okay, right. Suppose if you want to access an element in arrays, there is a way to, through the indexes, array of 0, array of 1, array of 2, array of 3, like that. You have a ways to that accessing the elements, right? Then how can you access an element here? Next one, access, accessing elements. Okay, accessing elements. Okay, how can you access the elements? Here you have a method of get. Okay, get is the method to add, or suppose, sorry, to access the element. All are the methods. So suppose list1 list2 dot, I want the index 1 element, list2 dot get off, list2 dot get off. Get is the method. In that method get off, here you have to mention the index. In this add you have to mention the element to add. In this add all you have to mention the collection. Okay, you have to mention the collection. Get, how can you get an element or get element at particular index? Through indexes only you can get it, but how can you get it is 100, right? 100 is in the one, the same way. But here if you want to, if you are try to access like list 2 of 0, list 2 of 1, list 2 of 3, like that, it will throw an error. Why? Because in the collections the way only is the through get. Remember the thing, what are the methods we are discussing the for the array list? Those all are similar to the vector also. Those all are similar to, most of it similar for the linked list. Some are beyond that, other than the array list also linked list contains. And for the stack it will be the different. Stack contains I think 5 to 6 methods, but some similar methods are there. The similar methods are nothing but contains. Contains is one method. We'll know, we'll see that. First one, get list 2, right? By default if you observe, if you are using the add or add all, if you are using the add or add all, the elements can be inserted at last. Elements are inserted at last. Suppose you are intent to add an element at particular index, add element at particular index. In the add we have that index, you can mention here index, and the what the element you have to be add at the particular index. Okay, I can add list2 dot, suppose first here I can print the 6 out of list2. Okay, first I can print that list2, and after that list2 dot, list2 dot add of my index is suppose 1 comma, my element is 0. Okay, at the first index I am trying to insert the element of 0. Then after that only, after that also I can print that sys out of list2. And after, if you are list2 dot get 1, get of 1, that means first index what the element I can store 0, right? So here I can get the output of 0. Here what the output I can get? I can get the output of 10, 100, 10, 100, 10,000, right? Here what the output I can get? 10. In the first index already 100 is there, so 0, 100, 1000, that means 10,000. If you observe, it has to be expand the array list and allocate a space at that index and insert it. Okay, create a space at that index and insert the element. We'll run it. Right, but your intent is not like that. uh, add also similarly work like that. Suppose add all some index, particular index, you can start that list of elements, then add all of index also can work. I means index comma ele. Okay, this is the way you can access not element, add all, go with the collection. Add all, go with the collection. Okay, remember the thing. In the insertion, first we are discussing insertion, add all, add at particular index, add the collection at particular index. And how can you get it is through index only, right? Suppose this is the accessing element, second one, right? Your intent is to replace an element. Third one, replace element. Replace element, right? In before, what it do, it will not replace as the 100 with 0. It will expand the list or moves the list in the right side and create some space at the index 1, create some space at the index 1 and insert the 0. But you are intent to remove, that means replace 100 with the 0. Okay, replace 100 with the 0. Already 0 is there, right? So I'll do one thing, replace 0 with the 1. Okay, for that set 0, 1 comma 0, and here I can print this out of list 2. Okay, right. Not replaced, huh? Okay, I'll 0 with 0, I'll do 1 at the index 1 element, what we have to be replaced, right? So 0, I am replacing the 0 with 0 because of that. Now the 0 is replacing with a 1, right? Add is different, add at particular index is different, replace an element is different, accessing, how to access is different. Okay, what the methods you are remember, add all, add at particular index, add all at particular index, get the element, set is the method. Okay, right. Next, insertion, accessing, replace, fine. Replace is nothing but a update, right? Particular element is there, you are updating that particular element, right? Replace is nothing but update. In the same way, next, delete. How can you delete? We already see the how to create a list and how to access the elements and how to add the elements, that means insertion. And next, remove, right? That means how to delete an element from the array. Deletion. In the deletion, we have the methods of remove, removal, right? Here I have the list 2 of 10, 10, 100, 10,000, right? This is the remove and remove all, right? So I want to remove the 10. I want to remove the element of 10. Simply list 2 dot remove of list 2 dot remove. List 2 dot remove. In this you have to pass the element. Which element you have to be removed? That element you have to be passed. Suppose I want to remove the 10. Then sys out of list 2. Index out of bound, right? So you can pass the sorry here through the indexes you have to do. So suppose I want to remove the 0 zeroth index. Remove is the method to remove the elements. You can simply pass the index which you have to be removed. This is the remove. Like the way we already seen that insertion by using the add and also accessing the elements and replace the element and deletion. For the deletion you have to go with the remove. Deletion you have to go with the remove. Remove all is nothing but suppose you want to remove one collection, if you know exactly it was there, then you can go with the remove all. In the way uh, suppose you want to know what is the size of your list. Normally arrays you can use the length function, right? The same way here you can use the size is the function to know the how many elements in your collection. Sys out of here I can get the list 2 dot size of. It is the method to know the how many elements, likely simply length of the array you are finding by using the size here. Size is the method to find the length. Okay, it will return the 3. It will return the 3 as a result for the size. Why? Because right, size is the method to know the how many elements in your collection. How many elements in your collection you can know by using the size method. Okay, and right uh, now we can see the how many ways you can traverse in a collection. Traverse. Okay, traverse. Okay. First way, traverse is nothing but how you have to print the all list of elements. You are intent to print all list of elements in array. How can you do? Simply by indexes. For I, for int, that means for I, for int I equals to 0, I less than or equals to array dot length I plus plus array of I. The way you can go, simply you can use like this here, but in place of array of I, here you can use the get. Suppose we'll do one thing. Suppose you have an array int array arr equals to 1 comma 2 comma 3 comma 4. You want to print every element. How can you do? Simply in the arrays, the one way is for int I equals to 0, I less than or equals to arr dot length of, sorry, and I plus plus, right? Simply you can print like a sys out of arr of I, right? This is the way you can go by indexes. And simply in normal arrays, the way you can use like this for traversing. For suppose I want to print the list 2 of elements, then simply I can go like this also, right? For int I equals to 0, I less than how can I find the size here? List 2 dot size, I plus plus. Simply how can I access this out of list 2 dot get of I. Fine, right? The same approach. In place you are using the arr of I, like this you are accessing the elements. Here you are using the get method, right? There you can use the length. Here you are using the size of method. And also another way we already know, right? That is for each loop. For each loop. Suppose I want to print the for each loop array. How can you print? For each loop or element based traversing. This is index based traversing. Index based traversing. Okay, index based traversing. It is element based traversing. Index based traversing and element based traversing for int sorry okay, fine, all are the integers, right? For int I colon list 2. We already discussed this at the time of arrays. Simply here in place of list 2 you can place the arr, then sys out of I. Here I means element, exact element, not index. Exact element. I will be the 1, I will be the 2, I will be the 3, I will be the 4. That means reference of the element. In before it is the indexes. Here now it is element. Simply what are the data type you are storing the elements, then you can mention it here colon, and what are the collection type. This is the one way. It is element based traversing. It is element based traversing, like the way, sorry, okay. And another way is also there, through iterator. It is not in arrays, it is not in the arrays, it is only in the collections. It is the difference, only thing. How can you create an iterator? We have the one iterator class. Iterator class. Suppose iterator, that iterator accepts the data type. Iterator accepts the data type. Suppose my data type is the integer itr equals to itr equals to right list2 dot iterator. This list2 is nothing but collection. It is the collection you have, okay, and what is the, it is the object reference. Suppose if you are not mentioning anything here, then it will be taken as a object type, then you can print like anything. Suppose if you are do like this, then only integers can be accessed. Suppose your list1 is a string type, then it will not access, okay. Then how can you print this? Simply what you are doing this all is a list2 collection, you are converting it as a iterator. Actually your list2 is there, your list2 collection array list was converted to the iterator type. That iterator type has the two methods, I think. One was the has next, one was the next. Has next and next. Simply two methods it has. Iteration has the two methods. One was has next, I think. Has next. Another thing was next. What are those two methods will be do is has next checks the next element exists or not. Okay, has element checks the next element exists or not. Next returns the next element. Okay, simply while of itr dot has next. Okay, iterator has two methods. One was has next. In this while loop, simply sys out of itr dot next. This itr dot next, simply imagine like the thing. Suppose 10, 100, 1000. Here you have a 4 elements. Here you have a 4 element. Has next, what it do is first itr is at the not at any element. First itr is not at any element. itr is at empty location. Okay, itr at empty location. Itr first check has next. Has next means next elements exist in this or not. 10 exists, right? So itr dot next. Itr dot next, what it do is it will print the itr is at currently at outside the list. So it will print itr dot next means it will print the next element. Itr dot next means it will print next element. Suppose now itr is at 10. Now also it will check itr dot has next. That means next is there or not. So itr next move to here, right? Next itr has next or not. Next itr moves to here. Itr moves to here. Next here it will check itr has next. It will not there. So this loops will fail. So it will not goes to the itr next. itr next helps to move to the next element. Prints the current element and moves to the next element. Right? Simply run it and save. All the now I can get the output of I think 10, 100, 1000 in a multiple times. Why? Because I am go with the all the loops, right? So 100,000, 100,000, 100,000. All the ways are the same. How many ways you can traverse, I will show. These two ways you can go with the arrays also, but this is the way you are going with the only collections. These three ways are same for the array list, vector, linked list, sets, queues, stack. These three ways are same for the every collection framework. For the maps also. Okay, right. And we have to discuss some methods. Those methods are, first one, contains. Okay, contains. I'll comment this all. 80 lines. I'll comment this. Now we'll see some more methods. One was the contains. Okay, contains is the method checks an element exists in your list or not. Suppose you want to check 10 is in your list or not. List or not. Normally what you can do, simply you can go with the for loop, traverse to the every element, check the element is in there or not. You have some predefined methods like contains and all the things, so simply you can use that methods and check the elements exist in your collection or not. Contains, it returns true or false. True or false, only two things, true or false, it will be written. The thing is, suppose sys out of I want to check uh, list 2 dot contains of suppose 1000, sorry 100, then it will return true. It will return true or false. Okay, this is about that array list, all the things. And one thing I have to tell, vector is also same like the array list, but the difference is, array list is the new one, vector is the old. And also vector is a thread safe and synchronized. That means suppose thread safe is nothing but you have a one list, you have one list, some threads, some multi threads, one or two threads try to access the array of elements at a time, that single array of elements at a time, then your vector not allowed to that, but your thread will be allowed to. That means array list will be allowed. That is the difference, only difference between the array list and the vector. I'll show that the difference. I'll create one class. New class. My class is vector, vectors. Okay. Mm, fine. Fine. Okay. How can you create a vector? Vector by using the class name. Class name is the vector. Vector, simply you cannot mention anything, or you can mention the same way, but the class is different. v1 equals to new vector. You have to import it. Import java dot util dot star. Okay. Okay, if you are not use anything, then you are not mentioning anything. Okay, generics. Fine, this is the way you can create a vector. Like the way what you are creating for the array list, by using list also you can create, but in place of array list you can simply use the vector. Replace the array list keyword with a vector. And the difference I will show. First, array list, how it is different from the array list. I'll write it here. How the vector is different from the array list. First thing is thread safe and synchronize. Thread safe and synchronize is nothing but, we already discussed that multi-thread concept, right? In the multi-thread concept, some data or some resource accessing by two or more threads at a time, then there will be a chance for the rest condition. For that we are using the synchronized. In the same way, vector is a pre-built, your Java provides the synchronized list. That means the same v1 is there, this v1 is tried to access by the two threads at a time, then it will only allows one. After completion of the one, only it will allows another. That is the difference. That is the main difference between your vector and the array list. And this is one difference. And another difference is capacity. It is nothing but, suppose here only I can take the array list. Array list a1 equals to new right. Array list a1 equals to new. I'll take the one vector and one array list. First I'll see the capacity of a v1. Simply this out of capacity is a method. Capacity is different, size is different. Size returns the how many elements in your collection, but capacity is different. Capacity defines the how much it can able to store. Yes, suppose s1 is not there, right? v1 dot capacity, right? v1 dot capacity, v1 dot capacity. The same way, this out of a1 dot capacity. Okay, I think it has some no capacity method. Okay, first I'll show the a1 capacity. Capacity. Wait a minute. Okay, first you can know the capacity of v1. The capacity of v1 by default it will shows the 10. By default first it will shows the 10. 10 is the default capacity for the vector. For the array list also the same. Default capacity is 10. But the difference is, normally what I said before, array list is resized. Okay, resized. That means if automatically strings, and that means automatically shrink and automatically expand based on the elements. Suppose I'll show that. That means first the initial capacity is 10, right? That means it has to be capacity to store 10. Then what will be happen after storing the 10 elements? Capacity is different, size is different. Size is now exactly how many elements is there. Capacity is nothing but what will be the capacity after the size is finished. Okay, We'll see. Suppose for I'll append the elements for int I equals to 0, I less than or equals to 10, I plus plus. Simply I can add. How can I add an elements? V1 dot add of v1 dot add of I. Okay, v1 dot add of I. Okay, fine. V1 dot add of I. That means I can add the 11 elements here. Then I can check the what is the capacity of the V1. It will be becomes 20, 10, 20. Now my V1 capacity increases to the 20. Suppose if here only I can check the size. It's out of V1 dot size. All the methods are same. What you are using for the array list, both all are the same for the vector also. What is the element? 11 elements, but the capacity is 20. Suppose imagine the thing. The 20 elements also finishes. Then the capacity becomes 40. If 40 also finish, then the capacity becomes 80. That means vector size can be automatically changes 100% of the current capacity. Okay, 100% of the current capacity. But array list is 1.5. That means half of the current capacity. That means 10 will becomes 15. Okay, 10 will becomes 15 and 15 will becomes 15 means half 24. Okay, that means how much the current capacity is there into 1.5. This is into 2 capacity. Okay, fine. Capacity increases into 2x to current capacity. And but array list 1.5x. 1.5x to current. Okay, it is the thing. And another two methods I forgot to mention. One was the clear, one was the is empty. Remove method is what it do. Simply here you can print the first sys out of v1, sys out of v1. One method is there, that is empty. It will check your collection is empty or not. It will return true or false based on the uh, existence of the elements in your collection. It will return true or false. If your collection is empty, then it will return false. That means collection is empty. In English word is empty. You are checking true or false. If collection is empty, it will return true. If collection is not empty, it will return false. Okay. And another thing was clear. Okay, first clear. There is a difference between remove and the clear. Remove deletes the particular element. Clear deletes the entire collection. That is the difference. We'll check that first. Here I can print the v1 I will print. After that I'll print the sys out of v1 dot is empty. It will return false. Why? Because my list is not empty, right? So that now what I'll do is v1 dot clear. For the array list also the same, v1 dot clear. That means clear is the method for removing that. Next I will print here what it is, sys out of v1. Fine. Next here I can check the is empty method. Sys out of v1 dot is empty. Now it will return true. Why? Because my list is empty now. Right? What are the elements? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And is empty written false. Clear function what it do? It will remove the all elements in the array and it will return true. Right? This is the difference only the vector. Vector also same like the array list. The thing is it will thread safe, synchronize. The array list also you can change it as a synchronize by using the collections. We'll see that one. But the difference, the major difference is this and okay, fine. This is all about that. This is also the same. You can traverse and add and remove an element and all the same. Okay, fine. And some collection methods. Some collection methods I have to tell. I am not talking about the array list methods or the vector methods. I am talking about the collection methods. What are those collection methods? Is simply, suppose I'll remove this all. Beyond dot capacity. I don't want this. By using the vectors also I can explain it. Simply I equals to 10, I greater than or equals to 0. I'll adding the elements. Okay, that means it will order in the order of 10, 1, 10, 9, 7, 8 like that. I want to sort it. Okay, I want to sort the elements. How can you sort? Is majorly collections. It is also one interface. By using this you can do some methods or some operations. First one, sorting. Collections dot sort of, you can simply pass here your what the collection is there. Suppose I want to do with the v1, right? So v1, first I'll print here sys out of v1. Okay, that means what it do actually is simply your v1 can convert it into the sorted manner. That means your v1 will be updated. So sys out of v1 now. Sorry, it will goes to the infinite loop. It goes to the infinite loop. Never it will be end, right? What will be the error? Okay, it will show the before one. I greater than or equals to 0, I minus minus v1 dot add of I. Out of memory. Hey. Java heap space. Okay, I not save it. we are not save it, it will take the before one and run it. And another reverse is there, right? Sort is the method like this. It will update the exact collection. It will update the exact collection. And also in place. And also another thing is there. It was a reverse. Okay, reverse. We'll do one thing. Okay, a1 equals to collections dot I am not sure it will work or not. Collections dot reverse. Collections dot reverse of v1. Type mismatch. If it will be a vector, no, then it will be okay. We'll do one thing. Okay, for a while remember this. We'll check that one. Collection dot reverse of v1. That means it will reversing the what the elements it has. First initially it will here you can get at 10. That will becomes 0, 1, 2, 3 like that. Again it will be reversed. Then it will be print as it is before one. If you want to reverse a list, there is a option like this, or else simply you can do like normal programming approaches of arrays and all. First initially it will sort it, but I am reverse it now, so it will be becomes as it is like a print first one. And suppose you want to know the maximum element from the list, maximum element from the collection, then collections dot max of it will accept two one was listed to, sorry, v1, right? v1 max of v1, fine. Max of v1, it will return the maximum element from your vector, maximum element from your vector. It maximum element is 10. It will print already 10. Maximum element is 10. The same way you can go with the minimum also. Collections dot minimum of you can mention it. And simply suppose you want to know the frequency of an element in your array. I'll do one thing. I'm adding 10 to this, and after that I equals to 10 to 8. That means 10, 9, 8 will becomes 2 times, right? I'll making this as a control question mark and run this. You want to know the frequency of an element in the list. You want to know the frequency. The simply it will print a maximum and the array of elements. Suppose if you observe, it will maintain the insertion order. So 0, 10, 9 again, right? The same way what? Fine. I want to know the how many times the 10 will become. How many times my 10 will be repeat in my collection. For that, collections dot frequency. Okay, collections dot frequency of simply you can pass the what are the collection. My collection is v1, and element you have to fetch. Suppose I want to check the 10, then you can go with the 10. It will return something now, so you have to be store it in sysout. it will returns the count, the frequency of the how many times it will be repeat. Two times it was repeat. In before this sort also we can store, I think. Wait a minute. The type is the mismatch, so I'll do one thing. Control C, Control V. I'll go with the vector v2, and I'll try to store this in a simply v2 dot, sorry, v2 equals to, then also type not match. Okay, we'll do one thing. Type mismatch. Okay, it has the void type, but I am trying to convert it into the integers. Collections dot sort, I think not returning anything because of that. Okay, okay, fine. This is the some methods. The same way like max, you have the minimum also. Minimum returns the minimum element in that, and also shuffle is the method. Shuffle is the method like this. Shuffle method shuffles the list in a random way. Shuffle of suppose v1, you can write like simply shuffle of v1, then it will do your v1 into a shuffle manner, random way, not in a insertion order, maintaining random way. And suppose swap, suppose you want to swap the two indexes of elements, suppose 0th index and the second index, then suppose I think my first index contains the 10, right? Last element I don't know, so I'll do one thing. Dot collections dot what it is, shuffle not right, swap, collections dot swap of my v1. In that v1, it is first one is nothing but in which collection you want to perform. These collections means entire interface. In that entire interface you are calling one method, and in the entire interface which type you are doing, that means you have to mention, right? So first 0th index 10, right? My 0th index is 10, one index is 9, two index is 8. So I'll go with the 3 index 7. That means first element becomes 7, third element becomes 10. I want to print now sys out of v1, swapping of a two elements in a array. This all not for the vector, it will be for the array list also. Okay, 3 5, okay, sorted. Okay, it was sorted. When it was sorted, 1 and 0, 3 and 0 are the swap, right? And binary search is also there, collections dot binary search, and fill is also there, copy is there. Okay, basically these are the some basic methods. Why? Because sometimes there might be a questions like you have to sort the elements, then go with the different approaches. This is the simple method, you have the predefined, so you can use it. Fill is one method is there. Fill is nothing but you can fill the all elements with a one particular value. Suppose my array, or I want to fill with the all with the, suppose simply collections dot sort, fine, collections dot fill of, collections dot fill of v1. That means in which collection I want to do v1, I can fill with the all are tens, so you can do it now. simply run, and it will fill with all the tens. And I think one other, all are tens. And binary search, suppose binary search is also one important thing. Here I can use the binary search. Binary search returns something, right? Index I equals to binary search of v1 of 10. Binary search, what it do is actually is it will returns where the element exists. Suppose this 10 element exists at index 0, so it will returns the index 0, so I can print here as IE. Binary search operation returns the one value of where the element exists. It will checks, normally checks the for that. What it written 11. This one where it was last found, not where it has first found, where it has last found. Okay, where it was last found. In before I'll do that. Sys out of v1. 10 zeroth index 1 2 3 4 5 6 7 8 9 10 and 11. In the 11th index it will become, it will return the index where it exists that element. And suppose you want to store one collection into the other collection, one collection into the other collection, that means copy. Suppose collections dot reverse is there, right? I'll do one thing. In this collections dot copy comma v1 comma simply I think v2 comma v1. All the elements in v2 it will be print at the v1. Sys out of v2. Okay, simply you can store all the things into this. Index out of bound, right? Now it will not contain that, right? Because of that index out of bound, index out of bound. Fine, where it will come before index out of bound. It is not getting for this issue, it was getting for the v2 is a vector, right? v2 is a vector. What is the capacity of v2? It will be 10, but I am increasing my capacity of a vector to the 11 of the 20. That means 20 I am storing into the, or 13 I can store into the 10 size vector. So because of that always it was a source, where it is, it is a source, that means it is a destination, it is a source. Okay, it is a source and it is a destination. So I'll do one thing, I'll remove this one, size not matches, right? Because of that So always your destination is greater than the source size. So I'll go with the 5 array. Control S, save this. Source does not fit. Do one thing. Right. V2. I think. Wait a minute. I'll check. I'm not confident that it is the source, it is the destination, or it is the source, it will be the destination. V1 is destination, V2 is source. Okay, right. Ah, V1 is destination, V2 is source, so sizes are not matching. Copy is similar. You can copy the all element to that, but now V1 becomes the empty. Suppose here I can print the V1. My E1 becomes empty, I think. Right, where it is. We'll do one thing. Control C. V2 dot add of V2 dot add of I. Remove this all the things. Simply print this out of V2 and copy of V1, and here I can print the V1. Fine. And also print here V2. This out of V2. Now I can find the things. My V1 contains the 10, 9, 8, 7, 6, right? V2 contains the 0, 1, 2, 3, 4, right? What are the elements in the V2 will be copied to the V1, are copied to the V1, and then V1 becomes the same V2. This is the destination, it is the source. Suppose we'll observe one thing. Suppose I'll make it as a 4, then it will stores the 5 also. If you observe 10, 9, 8, 7, 6, 5, it is V1, it is V2. V2 is copied into the V1. That means these 4 elements swap with the these things, right? These 4 elements swap with the these things, and in the final, what are the remaining element is there? It will be exists in the V1. Copy means what are the elements in the source? It will be always destination size will be the greater than source. That is the thing. Destination size needs to be greater than source size. That will be the copy. Right. This is the some methods with the collections. Okay, fine. We are left with the stacks and the linked list in the list interface. We'll discuss in the next session. Fine. Practice on it, then it will be good. Thank you.